Hey Maroons, today we're starting chapter 10. We're looking at how to break really big polynomials down into really small polynomials. The factor theorem, college algebra with Mr. Forbes. Notes out and away we go. All right, so we're looking at how to break down bigger polynomials. To do that, we're going to use the factor theorem. So we're going to explore a little bit how this factor theorem works, and then we're going to define it. Again, what are we trying to do? We're trying to break down a bigger polynomial. So a polynomial function is a function that is used to define a polynomial. We're going to use the notation p of x to mean a generic polynomial. Could be a quadratic, could be a cubic, quartic, quintic, just any polynomial. We're going to recall that root or zero is this. If we plug a number c into a function, plug in 2, plug in 3, and we get a 0, then that number is called a 0. A number plugged into a function that produces a 0. Remember, we're going to call this number c is the root. It's the 0. It's also the solution. It's also the x-intercept. It's a bunch of different things. Those are all the same. We're going to explore the polynomial x squared plus 2x minus 15. And we're going to kind of see the properties, how the properties are going to work, and then we're going to come back and define those properties. Well, we did this all the way back in chapter 5 when we looked at factoring. So if we set this thing equal to 0, we know what would factor. X plus 5 times x minus 3. Therefore, we get solutions that are -5 and 3. We could also use the quadratic formula, completing the square, yada, yada. All those would get us the same solutions. Let's take those same solutions and plug them back into the original function. So if we look at f of -5, what do we get? Well, we get -5 squared plus 2 times -5 minus 15. And if you work that out, that's 25 minus 10 minus 15. What do you get? That's 0. -5 was a solution, but it's also a root or a 0, because if we plug that number back in, we get a 0. And that makes sense because we started this equal to 0, and that's how we got the number. What if we did f of 3? Well, that would be 3 squared plus 2 times 3 minus 15. That's 9 plus 6 is 15 minus 15. And again, we get a 0. So by checking numbers, we can see which zeros we're going to get. Those zeros, remember, are solutions. So this is going to be kind of a backdoor approach to get solutions. Show that the roots are zeros of the function. And we just did that. What else do the factors do to the polynomial? Well, let's look at using synthetic division. So our x was -5. If we use synthetic division with our polynomial, and that would be 1 to -15, what happens? Well, we're going to, again, to use synthetic division, we're going to drop the first number, that's a 1. Then we're going to multiply and add. -5 times 1 is -5. Add is -3. Multiply is 15. There's our 0. What do we get? Well, we got a remainder that is 0. Let's see what happens if we did the same thing with 3. With 1, 2, and -15. We're going to drop the first number as 1. 1 times 3 is 3. 2 times 3 is, 2 plus 3 is 5. 5 times 3 is 15. And again, we get a remainder of 0. So a bunch of things are going on here. The first, in the factor theorem, the remainder is 0 when the polynomial is divided by x minus c. So when we do synthetic division with a factor, a binomial factor, then the remainder has to be 0. We just saw that evidenced up here. Therefore, then x minus c would be a factor of the polynomial. C is also a solution to the polynomial. When we plug it in, it's a 0, right? Solution or 0 to p of x. And then c is also a 0 of the function p of x, or p of c equal to 0. So we're going to use those ideas right, to help us break down bigger polynomials. This is all code for, these are all ways to get solutions. Right, and that thing ever since 5th grade, right, how to find x. So let's do some example problems. This is a review from previous chapters. Use synthetic division to determine whether 2 is a 0 of the polynomial. Now 2 is already solved, you don't have to flip it. So this is saying x equals 2, is that a solution? Remember, if it's the binomial version, x minus 2, then we have to flip it to say x equals 2. We're going to write down the coefficients. So 1, -3, 5, -2. The number goes out front. And we're simply going to follow the rule. The first number drops, and then we're multiplying and adding. So the first number drops is 1. 2 times 1 is 2. Add 1 is -1 times 2 is -2. Add is 3 times 2 is 6, and we get 4. And that's correct. So we get a remainder of 4. What does that mean? Well, to be a 0, we have to get a remainder of 0. So 2 is not a 0 of p of x, because our remainder was not 0. So 2 is not a solution, is another way to say that, because we're looking for solutions. Determine whether -4 is a 0. So again, we're going to use our same process. We're going to use synthetic division. For our x to the 4th, the coefficient is 2. Note there is no x cubed, so we have to put a 0. -28, 14, and -8. And here again, we follow the same rules. We're going to drop the first numbers 2, multiply is -8, add is -8. -8 times -4 is 32, add is 4, multiply is -16, add is -2, multiply is 8, add. Here we do get a remainder of 0. What does that tell us? That tells us then 0, we want to note, is the remainder. That's important because if 0 is remainder, that tells us 4 is a 0, right? Solution to p of x, a polynomial. Example 3, use synthetic division to determine whether x plus 4 is a factor. If so, factor completely. So again, we're just reviewing previous ideas. We've already done this. Again, here we want to solve for x. So the number we're going to use is -4. We need to solve it if it's in that binomial form. So we're going to set up our synthetic division. And so our coefficients are 1, 3. There is no x term, that's a 0, and a 16. We're going to use the same rules. The first number drops, that's our 1. 1 times -4 is -4. Add is -1. Times -4 is 4. Add is 4. Multiply is -16. There's our remainder of 0. Now the neat thing, our original polynomial, so our x cubed plus 3x squared plus 16 then, it's going to factor. And we just found a way then to factor bigger polynomials. And that's the key to this whole thing, right? We didn't have any, our regular factoring rules didn't work for this. We can't use quad 4 on this. So now we found a way to factor out a bigger polynomial. Well, x plus 4 gave us a remainder of 0. So x plus 4 has to be a factor. What's left? Well, what's left is this polynomial. Remember, this is the remainder. So this is the number, the x term, and the x squared term. So what's left then has to be x squared minus x plus 4. And then we can come back and use quad 4 quadratic formula on this, complete the square, factoring if it factors also to solve it. And that's factored completely. So to factor it completely means we're going to come back, whatever factor we use goes first, and then whatever polynomial we ended up with as our divisor goes here. All right, let's look at a couple more. Let's look at example 4, and then I'll show you the shortcut method. We have the polynomial x cubed minus 4x squared minus 17x plus 60 equals 0 has at least one solution between -3 and 3. Find all of the solutions of the polynomial. Well, here then in lies the question, which one is a solution? And you don't really know, although later on we're going to get another theorem that'll help us kind of get a better guess. We just know that there's one integer solution between -3 and 3. So what do you have to do? Well, you're going to have to guess. So let's guess 2. So this is 1, -4, 17, and 60. And if we use our synthetic division, that's 1, 2, -2, 4, that's 21. Oh, it's a -17. Negative, I missed something. -4 is -21 times 2 is -41, -42, and that gives us 18. Well, 18 is not a 0, so 2 is not a factor, so that can't work. So let's try another number. Let's try -2. We'll do the same thing. So 1, -2, add is -6, times is 12, that's -5, that's 10, that's 70. Well, that didn't work. Again, that's not a 0. Let's try another number. Let's try 3. So we'll do the same process. 1, -4, -17, and 60. And we get 1 times 3 is 3, add is -1, multiply is -3, add is -20, multiply is -60, add is 0. So there's our first solution, has to be a 3. All right, so what happened? Well, our polynomial x cubed minus 4x squared minus 17x plus 60 equals 0 now becomes, we factored, out of 3. Remember to plug that back into the factored form, that's going to be an x minus 3. What's left? Well, that's this quadratic. Remember, this is the number, the x, and the x squared. So we're left with x squared minus x minus 20 equals 0. Now we want to find all the solutions. Well, this polynomial will actually factor itself. You could use quadratic formula. You can use your calculator. But this one factors, signs are different. Multiplies to give 20, subtracts to give -1 is x minus 5 and x plus 4. Therefore, we can get all of our solutions. All of our solutions then are 3, 5, and -4. We can check all of those by plugging them back into the original problem. We also know that there has to be 3 solutions because this was an x cubed. So there's all of our 3 solutions. All right, so that's the long form method, guessing and checking to see which polynomial. There's a shortcut. And so for this one, we'll see a shortcut. And the shortcut is using one of our polynomial rules. Solve x cubed plus 5x squared plus 3x minus 9 equals 0, given that at least one solution is between -5 and 5. Well, we just talked in our remainder theorem that if we plug in a number and get a 0, it's got to be a solution. So to find solutions, we can do it this way. Now, I did not want to do that on my calculator. And so here's the shortcut. Well, we could pick a number and plug it into this polynomial, see if we get a 0. That's one way. Or here's the even better shortcut. Let's put it into y equals. So this is x cubed plus 5x squared plus 3x minus 9. And we're going to go to table. And when we go to table, you're going to notice a couple things happen. The magic numbers we're looking for are the zeros. So the zeros then tell us what the solutions are going to be, at least the solutions that we can find, what they're going to be. Well, there's a -3 that gets us a 0, and there's a 1 that gets us a 0. So that gives us at least a number to check. Hopefully, it'll give us 1. It won't be guaranteed to get you an answer, but at least it'll get you at least a good start, something to check. So we know that -3 and 1 are solutions. we still have to factor down the bigger polynomial to see what quadratic we're going to end up with. So I'm going to go ahead and pull out a 1 as a solution. So we'll put this into synthetic division. So this is 1, 5, 3, -9, and we're using 1. He could have just as easily used the -3. I just picked the 1. So we're going to plug this in. We're going to drop the first number as 1, multiply as 1, add 6, multiply as 6, add as 9, multiply as 9. There's our 0. Now, if we get a 0 in table using the calculator, our remainder has to be a 0. If you don't get a 0, then that means you messed up the synthetic division. There's several ways we can approach this now. I'm going to show you a couple of different ways you can do this. So our x cubed plus 5x squared plus 3x minus 9 equals 0. That just factored. Because we got a solution of x equals 1, our binomial is x minus 1. That leaves us with the quadratic, x squared plus 6x plus 9 equals 0. That will factor again, x minus 1, x plus 3, and x plus 3. Therefore, there's our 3 solutions for our cubic. X has to equal 1, -3, and -3. Notice it appears twice. We're just going to actually include one answer. Later on in this chapter, we'll see what the second same answer does. So there are 3 answers, but 2 of the answers are the same answers. And later on, we're going to call that multiplicity. Here's another way we can keep going, right? We also know that -3 was also a solution. So we can do synthetic division. Again, we can actually just build off of our synthetic division. And here we go. Drop the first number as 1, multiply as -3, add as 3, multiply as -9. There's a remainder of 0. Therefore, what's our solutions? Well, our solutions then are the 1, the -3. Here we would have to opposite this 3, and that's our second -3. So those are a couple different ways you can find solutions to polynomials. Now, in subsequent videos, we're going to come back and talk about how do we know which numbers to check as zeros, and then also what the graphs of these things are going to look like. For your homework assignment for 10-1, we're on page 654. We're doing 8 through 40 and 44 through 52. Those are all evens. Have a good day, Maroons.